Hi, this is Team G ADM Project on Multivariate time series forecasting of prices using RNN. Aside shelter, food plays a major role in human life, and tomato seems to be one of the important fruits in food preparation. However, the price of tomato fluctuates over the year, and this fluctuation is mostly caused by weather, inflation rate, economic situations, festivals, and so on. And because of this, prediction of tomato prices is very important as it helps farmers and government in improving the decisions for tomato production and sales. And our work is to forecast the prices of tomato based on these factors using RNN.
Use five data sources for our ADM project, but this is our main data source which contain the prices of tomato. We try to extract this table using R, but still the URL is very static. We cannot able to do that. Even we try to use R Selenium, but still we found due to time constraint we cannot able to focus on more. Finally, we exported the three states of data using the export to Excel option.
Downloaded the inflation rate dataset from here, and here we have adjusted the filters on the web page. The inflation rate for rural and urban has been picked from the food and beverages group. This is at monthly and state level. Wages related to agricultural job has been picked from the Indian statistics site. Rainfall data has been picked from the data.gov.in site as Excel file at monthly and state level.
State monthly level holiday information has been picked from the state by changing in the year and the state, and we've written our loop to pick out all the three the month level festival information for all the three states under consideration. I've done certain diagnostic tests, and then based on that we've understood the nature of the data, and then found which algorithm best suits our dataset. And there are three tests that we've performed, which is basically the unit root test using augmented Dickey-Fuller test, and then we've tried the Granger causality test followed by the linearity test. The augmented Dickey-Fuller test basically checks whether a data whether we have stationarity in the data, and the results of the augmented Dickey-Fuller test shows that the data is non-stationary.
Causality test was actually one of the diagnostic tests carried out before the implementation of the algorithm, which is RNN. And this was carried out to check if there is any factor like rainfall, wages, and inflation rates causing any change in the price fluctuation. So this was done using Granger test, which I'm going to run. So you can see from the outputs that none of the factors causes a change in the tomato prices.
The third test we have used here is linearity test. This test has been used to decide the linearity of the data. Here we have used Harvey Collier and rainbow test, and the results were found that the test has no linearity.
So here we have the code for recursive feature elimination. So let's run the code and find which feature is good for our model. The subset of variables using the k-fold mechanism too, including it. The extracted factor which is plotted in the graph is clearly shows the accuracy of the subset of the variables. So we can able to easily find which variable, which factor is good and is good for our optimal model.
Decided which algorithm to use based on our results from the diagnostic test. We've run through a recursive feature elimination for every state to find which are the optimal parameters that needs to be used in the model, and we've looped through all these states with the feature selected using the RFE algorithm into the RNN. And over here we've adjusted the learning rate, the epochs value, and the hidden node. This is our hyperparameter optimization. So we are fluctuating these values in a loop to identify which is the right learning rate node and the epochs value. To identify the right learning rate epochs and the node value, we have used three parameters for evaluating the model, which is basically the r square map and mean absolute error. The output of one of the states is showcased here. So we've first filtered it based on the values where the r square is greater than 0, and we've just pulled out the record with the least mean absolute error. Over here this 227 over here means that the algorithm is able to predict with a absolute error of 227 rupees, which is measured in terms of quintal, which means that ideally our model is able to predict with a gap of 2.2 rupees per kg at a monthly level. So this algorithm can be scalable to all the 28 states, and the future work of this project is that after tuning the parameters to suit to fit the exact model, we can do it for all the 28 states and then cluster them to see which are the states that are having a similar type of price fluctuations, and that can be presented as a project to the government, and government can look into states that have similar price hikes and then take the decisions accordingly. Thank you.